What is the Future Farm project showing us? I'm Owen Gibson. I'm a researcher from Foundation for Arable Research, and I'm going to talk about our Future Farm project at the Chertsey site in mid-Canterbury. So observations so far. What have we seen if we've been running this project for the last 2 years? So as a quick overview, we've seen extra biomass in the conventional block compared to our Future Farm block, increased grain yield on the conventional block, which yielded 1 tonne greater than our Future Farm side. However, at a lower gross margin due to maturity differences between the peas, fewer operations in the pea crop. By utilising less cultivation in our Future block, we reduced our inputs. Soil moisture, we had a 5 mil difference in favour of a Future block by retaining residues and not cultivating compared to the conventional side. And that lasted for the whole project. Visual soil differences, we're monitoring soil aggregates and by VSAs through the system, and that's showing an increase in our soil health between the Future block compared to the cultivated block. Increased soil mineral nitrogen, as we can look further on. Increased biomass in preceding crops. Decreased pesticide usage in the Future block compared to the conventional, and increasing carbon stocks by limiting cultivation, which also leads us to some less greenhouse gas emissions, particularly from fewer operations. So about a project, what are we doing? It's our 2 hectare block at our Chertsey research site that we've split in 2. One is a conventional system and the other is a future farming system. All our systems and operations are recorded, and we're trying to look at our financial costs, impact on soil and crop structure, and environmental effects between the 2 blocks. And this is all planned by a steering committee, which is made up of farmers, industry professionals, and also FAR. So starting point, we went into green feed oats, coming out one of our trials, where one side on the conventional side with the cows, we grazed before ploughing and top downing. And then on the Future side, we rolled the oats flat, and we used that as a thatch mat to reduce weeds coming up. And we direct drilled in with a cross slot drill the resulting processed pea crop. This is what we looked like in early establishment, but pretty even. This crop was harvested on 24th December, and then we direct drilled buckwheat in on the 8th of January. And we kept that the same on both sides. This was the buckwheat crop full flower before harvest in April, and the resulting wheat crop that was planted in early May. And the wheat crop getting harvested in late March. So we talked about our visual soil differences. So this is what we're seeing as of 2024. We're due to do this again in a few months. The conventional side, we've got aggregate stability of 12.6 compared to 16.2 in the Future side. Obviously, we did full cultivation early on in the conventional side, whereas in the Future side, we've direct drilled for the crops for the last 2 seasons. Our penetrometer results, this is looking at our compaction across both sites. We've got the Future Farm side on the orange bar, and the conventional side is the blue. So as you can see, there's not a lot of difference, a little bit less, up to 35 centimetres in the conventional, and then it evens out down at depth. So what are some of the key things we're starting to pick up over the last 2 seasons? So nitrogen and soil test. Coming out of a buckwheat, we did soil test, and we found from a buckwheat we had pretty much the same grain yield, with only 100 kilograms difference. Straw biomass, we had a tonne more on the conventional side, but that didn't relate to the grain yield we just talked about. The uptake in the grain and straw was essentially the same. So the total uptake of around 135 kgs of nitrogen a hectare is what the buckwheat took up. But what was interesting when we came out of a buckwheat is when we soil sampled, we found we had 80 kilograms extra nitrogen in the future side. And now this is coming from the previous pea crop, where the conventional side, we baled the pea vines. In the future side, we retained all the residue and we just drilled the crop back in. We have to be careful. We can't just pick one thing that is causing this extra nitrogen. Obviously, a project like this, there's a lot of different aspects going on. So we can't just say it was the retaining the residues that did it. It could be we're putting trichoderma seed coating down at each time. So we could be increasing the soil health, which is allowing more mineralization or better rooting depth in the future side. But it's interesting to see anyway. I have there $140 extra urea. This was back in 2024. Now that a dollar value for 80 kgs of extra N is more like 155. So technology coming into the system. This, when we're in the autumn wheat crop, we applied all applications were applied by drone. That was after sowing and our base vert. So all chemical applications were done by a drone, and also all the nutrient applications were done by a drone. So what is this showing us? Obviously, we had issues when we were applying it. As you can see in this photo, there's stripping going from north to south, which is on a 45 degrees across the paddock. And that's showing out we had uneven spreading across this paddock. And also you can see along the headland, particularly between the laneway, between the two blocks, where we haven't had good spread uniformity across the block. We can see that in our satellite image on the left. You can really pick up the red banding going across the paddocks. On the top of the screen, you can see what we did a drone spread pattern. So this was each tray. We put trays out in the field when we were applying it. They were 2 meters apart, and you can see the uneven distribution. And then the bottom is water-sensitive paper that we applied across the paddock when we're spraying. And it's not probably quite so bad, but there are some worrying signs here with some of the papers not having a good pattern on them. I'll have to say, though, before I get into the next screen, is that we're not against using drones. In drones, we have seen really good results of doing spreading and spraying with both of them with good uniformity. I think it's just making sure you're comfortable with the operator you're using, and you're talking about what you're doing. We were trying to push the boundaries a lot from the early days with variable rate spreading and different techniques. So the autumn wheat yield. So what have we seen? This came off in March 2025. Plant counts were the same going through the season between the two systems. A wee bit of a difference in our 1,000 grain weight. I have to actually add that the difference between these two and the wheat crops was the Future Farm was a tri-mixture. So we had Graham, Voltron, and SY Defiant mixed together to try to offset our genetic resistance that we can get through by planting a monoculture. I think Jo Drummond from FAR, I like to steal one of her quotes of, we're creating an obstacle course to prevent genetic resistance to our pathogens with our fungicides. And whereas the conventional side was drilled with just straight Graham, and both sides at 90 kgs a hectare. So obviously our 1,000 grain weight was a wee bit higher in the conventional and the straight Graham. Total biomass was 2 tonnes more in the Future Farm trial, which related to an extra tonne of yield at 13.9 in the future side compared to 12.9 in the conventional, which both had the same harvest index of 56%. So how did that relate to our greenhouse gas emissions over this season? So we can see our biggest change is in our fertiliser application. I have to add that by using soil tests, we reduced fertiliser application by 40 kilograms a hectare on the future side, and that was primarily by using our PMN values to see that we'd have 40 kilograms of extra nitrogen becoming available over the season, which we changed in our fertiliser requirements. So the main differences in the emissions is the way that the products are produced, and that's where we're getting the biggest emission values. So it's the manufacturing of the fertiliser which is causing the biggest amount of greenhouse gas emissions within this crop. So a 3-year grid soil sampling. So we've set out grid sample points through the paddock, which we go back to every single year, and we monitor how those places are changing over time. And to me, when I got back our samples this year in 2025, our Olsen Ps have continued to drop, which to me is actually quite worrying. So obviously we're not nailing our nutrients within the paddocks, and we need to do a better job. If we look at organic matter, which is actually increasing on both sides, but we're 1% more in the future farm trial. However, I do have to relate that if you look right through the profile, there's actually very little difference. You could say there's no difference, but having that 3.9% extra organic matter, well, not extra organic, having extra organic matter in your top 0 to 15 centimetres is where it's doing the most work for you. So even though we do have the same through the profile, it is advantageous to have it higher in the top 0 to 15 or 0 to 30 centimetres where our main root mass is. And where to from here? So the crop is just about to get planted into 360 perennial ryegrass. Some of the major differences between the two blocks, we will cultivate the conventional side with a min-till, most likely top-down cultivator, 2 passes before drilling with hopefully an Avatar disc drill, putting down base fertiliser at the same point. We applied just recently superphosphate to both sides as a blanket operation on the conventional side and as a variable rate on the future side. The future side, we're going to direct drill the ryegrass into the wheat stubble, which at time of harvest we cut and spread and chopped at the back of a combine, whereas we baled on the conventional side. As the crop's going through, we'd like to see utilising drones again for our pesticide inputs as well as our nutrients. And one thing we'd like to play with is a variable rate PGR on the ryegrass. One thing I'd like to say is a big thank you to everyone who's been involved in this project. It's not just FAR, we're relying on a lot of other people in the steering committee and other professionals to help us make these decisions. And without their help, we wouldn't have this project running to the level that it is. Thank you for listening to me.